About 2 hours ago, right after we came back in for break, I introduced you to this fancy schmancy word that makes you sound sophisticated when you say it. Especially guys in here, if you want to impress the ladies, you can say this word a little more often. It's called the word coefficient. If you want to impress ladies, just say the word coefficient at a party or sometime. I'm not sure. You'll get a lot of phone numbers or whatever. But the word coefficient, check it out. The word coefficient is just a fancy, let me talk here, a fancy schmancy number or word that means the number in front of a variable. The lead coefficient here is 2. The coefficient there, the number in front of the x squared is 1, even though we don't see it. The coefficient here is a -5. So whenever I see the word coefficient, it's just the number in front of the variable. That's all it means. Nothing more, nothing less. Now, back over here. We're on number 15 together. Watch this. So I got what kind of polynomial would this be called? 3 terms? What is this? Trinomial plus another trinomial. Watch this now. What's the coefficient here? 1. Coefficient here is 3, and then we got 5. That's a constant term. It's a number. Coefficient here, -1, 6, and then -4. My board's a little bit off here. So I got a -1 there. So I got a, forgive me. Let me erase my hang tight. So we're going to deal with the coefficients. When we combine like terms, watch. Hopefully let's straighten it out here. So we got a -1 coefficient, +1 coefficient. So when we're combining polynomials and we're adding them, all we do is combine like terms. For those of you who forgot what like terms means, you might want to write this down somewhere on the margin of your notes, because you do what you want with these papers. I don't collect them. So the word like terms means same variable. If you know what a like term is, don't even write this down. But those of you who are rusty at math and you're like in outer space, you don't know what's going on right now, you don't know what like terms mean, you want to write this down. Like terms means same variable raised to same power. Raised to same power. So let's see. I'm telling you, when you combine polynomials and add them, you have to combine like terms. So let me look for the like terms. 1x squared. Is there any other x squared? Yeah, it's right here. Let me combine them then. Okay, let's combine by adding the coefficients. 1 plus a -1 is 0. 0x squared. But 0 times anything is 0, so it's gone. 0 times x is 0, so I don't have to write anything there. So those actually canceled out. It's gone. 3x plus a 6x. Look at, they're like terms because they have the same variable, and that variable is raised to the same power, namely, Jim, 1. So I'm going to combine like terms. 3x plus 6x, 9x. We're done. And then numbers with numbers. 5 plus a -4. 5 plus -4 would be a +1. We're done. So a trinomial plus another trinomial became a binomial. This concept that you learn in Math 1 or pre-algebra, like terms, is going to play a big role right now as we do these. Again, trinomial plus another trinomial. Let me get like terms together. T squared, 2t squared. They have the same variable raised to the same power. 3t cubed, -2t cubed. Look at those two are like terms. I'm going to combine those. And then I got a -3. There's no like terms with the normal numbers. And I got a +7t. No like terms there. So let me combine the t squares here. I'll circle them. What's the coefficient here?
1.
Thank you. So I got 1 plus a 2. I got 3 t squareds, 3 of them. How many t-squares do I have? I have 3 of them. There's 1 of them, and there's 2 of them. There's 3 t-squares. I like to cross them out when I'm done, just so I know in my mind I'm proceeding in an organized manner. All the stuff is clear. Once I'm done with it, I clear them out. Okay, 3t squared, or 3t cubed rather, the third power, minus 2t cubed. Coefficient 3 minus a 2 coefficient is a 1 coefficient. So 1t cubed. Because 3 minus 2 is 1. But I'm a professional in here. You guys are professionals, so we don't have to put a 1 because it's always understood to be there. We're just going to put t cubed because there's automatically understood to be a 1 there. Let me cross those puppies out. Questions so far? Questions? I trust I'm not going too fast. Uh, 7t, there's nothing to combine it with, so I'm just going to add this to my final polynomial. Doesn't just disappear. And the minus 3, I'll add that to my final polynomial, and here's our final polynomial. It's a 4-term polynomial. But it's unprofessionally written. Why? Can someone tell me why it's unprofessionally written? Standard form, perfect word too. Standard form, highest exponent first. So let me rewrite this. T cubed. This is a positive 3t. Look, it's positive. I'm going to keep it positive. 3t squared. Plus 7t. Minus 3. By the way, minus 3 and plus negative 3 mean the same thing, so it doesn't matter. Minus 3 plus negative 3 mean those are equivalent expressions. So this is our final answer, not this one. Put it in standard form. Highest to lowest exponents. Question so far? Now, some of you on assignment 8 who are not familiar with subtraction of polynomials, you got to pay attention now. I think I had a few already done with assignment 8 because they already know what's going on. When I subtract polynomials, you got to remember something now. There's actually a negative 1 here in front of that second polynomial. That negative 1 I have to distribute. So right now I want you to absorb in your mind, all we've been doing so far has been adding. Now when we subtract polynomials, you have to distribute a negative 1 here and here before you combine like terms. That's the only thing you got to remember. The rest is the same thing. The rest will be proceed as normal. Watch this. Negative 1 times 3 is a negative 3. Just keep the g. Negative 1 times a negative 6. Negative times negative is positive 6. And let me bring down the first binomial, g minus 4. And we're ready to rock and roll. Combine like terms. Coefficient here is 1, so 1g minus 3g. How many g's would that be? Negative 2 g's. Cross those out. Negative 4 plus a 6. Take a set of bigger number, subtract. Here's our final binomial. Let's try 18 together. We're subtracting, so let me distribute the negative 1. Phone's away right now, it's on the floor, and there, so we go. So I got negative 1 times a 7 will be a negative 7, h, plus negative 1 times a 6, negative times a positive is always, anytime the signs are different, it's always negative. Negative 6. I got a negative 5h minus 2 over here. I'm going to take it out of the parentheses now. Now I'm just going to combine my like terms. Don't break my heart, Sylvia. Come on. Negative 5 minus 7. Negative plus more negative. Look at it. I can put the plus negative here now. Remember, don't confuse that with multiplication. Negative plus more negative is still negative. If you lose $5 and lose 7 more bucks, you lost a total of 12? Yeah, negative 12. Negative 12h. like to cross them out when I'm done. Negative plus more negative again is still negative, right? You lost $2 and lost 6 more bucks. You lost a total of $8. There's our final binomial. Uh-oh. Binomial not minus a trinomial now. We started off easy with binomials and binomials. What about a trinomial now? We're going to subtract a trinomial from a binomial. What the heck's going on here? Well, we're subtracting, so let me get my -1 going again.
So if we're subtracting, there's going to be a 1 there.
There's always going to be a -1 that we'll have to distribute perfectly. That's what I want. That's what I want to get through to you right now before we leave home today. -1 here, distribute. -1 here, distribute. -1 here, distribute. Let's do this. -1 times a -3. Negative times a negative is a positive. 3x squared. Harmona, we're good? You have a notepad I gave you? Darn it. Number 19. -1 times a... What's the coefficient here?
1.
Close. There's a -1 there. Coefficients. Look at -1 times a -1. It's a positive 1x. Notice how I didn't write the 1 because we know there's a 1 there. It's more professional not to write the 1. Right, Medina?
No.
-1 times a -8. I got a positive 8. We're rocking and rolling. Let me bring down the first binomial. -x squared minus 5. This is a positive 3x, so I'll put a plus there. The rest is just combining like terms. Okay. What does like terms mean? Same variable raised to the same power. So this one and this one I'll combine because they have both x's to the second power. So -1 coefficient plus a 3. -1 plus a 3 be positive 2. X squared. Cross them out. -5 plus an 8. So plus 3. And then I got a plus x. I can't combine the x with anything. But let's put it in standard form. 2x squared plus x plus 3. We're rocking and rolling. I'm going to do number 20 in dotted blue, and I'm going to go fast. I'm going to go fast now. -1 here, distribute here, distribute there. The -1 since we're subtracting. -1 times 5 is a -5, k to the third. -1 times 7 is a -7k. A -1 times a -3 is a positive 3k squared. Let me bring down the first trinomial. K squared plus 6k to the third minus 4. Now we're going to combine like terms. One k squared, 3k squared makes 4k squared. Cool. I'll cross them out. You making fun of my writing again? Cool. Oh, Horton, what was it? 11k to the third. Look at this. 6 plus. Hold on. Careful, huh? We got a -5. So what would it be? Right. So we got a plus 1k to the third. Again, I'm a professional, and so are you. So don't put the 1 there. It's always automatically understood to be there. Bye to that. -4, I can't combine with nothing. There's no other numbers to combine it with. I got a plus -7k. I can't combine that with nothing. Now let me put it in standard form. K to the third. Okay, this is positive 4k squared, so I'll put plus 4k squared. Minus 7k. Minus 4. I could put plus negative 7k. Or negative plus negative 4. Same thing. Give me 10 more minutes of productivity. Don't just slack. Just 10 more minutes, and we'll close up after stamp sheet out. Give me just 10 minutes. Let's go. Finish up any assignments you're working on.